Let's look at transformers. So we've got a model transformer here. What transformers do, they're very good devices at using electromagnetic induction. So a transformer has got an iron core, and for A level, you need to know that this iron core is better if it's laminated and it's in sheets, okay? We'll leave that for A level. On the left side, that's called the primary coil. On the right side, that's called the secondary coil, which you can actually reverse. So how does it work? And I want to show to you that on my primary side, I have got around 10 turns. So I'm going to put that in here, that's 10 turns. Notice that the electricity is not directly connected to the secondary coil. So the coils do not actually touch. So what links them? Well, what actually links them is the magnetic field. There's a change in magnetic field here from the AC that cuts across the secondary coil and it induces an EMF like we've seen previously. However, the iron core permeates that field much better. And let's have a look. So I'm actually using 1 volt. I'm actually supplying 1 volt to my transformer. But look how much is coming out. 30 volts. So that's 3 times as high. That's interesting. There's an equation for that for GCSE. I also want you to notice that if I take the iron core off, we don't get 30. So the iron core helps in making the magnetic field link to the other side. One more thing that we're going to try and do is connect that to DC. And let's see what happens. Any predictions? There you go. 0.3 and around 1. So very, very small change in the actual voltage because our DC may not be a proper constant, maybe fluctuate a little bit. Transformers don't work with DC, they only work with AC. And over here, we've got a different one. So this, as you can see, in this example, the iron core is just a square, so you got the left side, you got the right side. Sometimes what they do, they mount the wires, the primary coil and the secondary coil right in the middle. And sometimes that just allows for a good connection, good flux linkage to the other side. We're using a transformer to teach our students what is induction heating. So we've got a little transformer here. This is our iron core, okay? And I'm just going to put that on top later on. And on the left side, I've connected that directly to the mains. So the mains uses around 230 volts. And obviously, I've got loads and loads of coils. I've got around 1,200 coils. What does that do? Increasing the number of turns increases the magnetic field. Okay, so again, I've got a little disc here that I'm going to fill up with water. Do you know what's going to happen? Well, have a look. You could see the bubbles there. I don't want to measure that because it's quite dangerous. I'm going to switch it off very quickly. They say induction hobs are better for cooking. And not because it makes better dishes, it's because it heats up almost straight away. There's no filament. It's not heating up the filament. What it's actually doing, it's using induction to heat. Okay, on to our next experiment. A bit warm. Called electromagnetic welding. Right, so the iron nail is put on this side. Close it just to cross-link that magnetic field. And once you turn it on, I want you to observe. I'm actually using not a flame to heat up this iron. I'm actually using electromagnetic induction to heat this iron. And notice how quickly this iron nail becomes red hot. There you go. Red hot. Imagine if you were to use a flame, how long that's going to take to heat your iron nail to become red hot. Ooh, and that's dangerous. I'm going to turn that off. Our last demonstration on transformers is showing the floating ring experiment, the famous floating ring experiment. There you go. So we're using electromagnetic induction again to make this ring float like that. Okay, so let's try and understand what's happening. So break this down. Again, I have got, I think this one is 3,600 turns. So it's creating a magnetic field. I just extended the magnetic field by having this iron core over here. But look, like your transformer, you got this primary side and then you got the secondary side. That's my primary side. And let's say this is now your secondary side. What happens? So as you turn this on, there's a field that's created around it. So the electrons experience that field. And because it's connected to the AC, that field is constantly changing. So the induced EMF here is in such a direction to oppose the change causing it. And that's what Len said. Len said that this induced EMF will be in the opposite way. And there you go. That opposite force pushes back up. And as a last little demonstration, I want to show you that if we do, look at it, turn it on, works. Turn it, put another one. Ooh, why is this not working? Well, this one works. They're identical, except that for this one, there's a slit. Right? For A level, we talk about eddy current, how that slit prevents that eddy current, which is why your iron core needs to be laminate sheets because it reduces the effect of eddy current.